Hello grade 10s and welcome to another video on algebraic equations where we're going to run through the whole chapter of equations. And I am sure, although this is going to be a long video, I'm sure it will stand you in good stead if you want to revise it before the exams that coming up, that you just want to make sure that you've covered all the types of questions that you can get. Alright, so I summarize it for you in this video. So the topics that we're going to be taking care of is solving quadratic equations, solving equations with fractions, solving simultaneous equations, solving literal equations, and lastly solving linear inequalities. Alright, so let's start solving quadratic equations. So this is quite easy, maybe more on a grade 9 level, or in grade 9 we have touched on these, although we haven't done like the trinomial and things like that. That's going to be incorporated here when we need to factorize. Okay, so first of all, step 1, we need to equal it always to 0. So it's already equal to 0 in A. Then step 2, so step 1, if I can write it here for you, equal your equation to 0. Step 2 is factorize, and then, step 3 will be let each bracket equal to 0. Okay, so quite short and sweet, although I know quite a few things get added to this, but that's basically what we're aiming for. Step 1 equal to 0, so already done. Step 2, factorize. So hopefully you can spot that this is a trinomial now, and the x splits, the signs are different. The first one is a minus, and then thus a plus next. And what times what gives you 14? 7 times 2. And minus 7 plus 2 does give you that negative 5. So x minus 7 is equal to 0, or x plus 2 is equal to 0. And when you become more comfortable, you can skip that step and immediately write the inverse of the minus 7 will be a positive 7, and the inverse of a positive 2 will be a negative 2. So either x is 7 or x is negative 2. Okay, if we look at the following, it's not equal to 0. So step 1, we need to equal it to 0. So then I'm going to have 21x squared plus 25x minus 4 is equal to 0. And now this is a trinomial. So if you can remember, I did do a video on this, your cross method. So what times what gives you 21? How about 3 times 7? And over here, what times what gives you 4? How about 2 times 2? So 3 times 2 is 6, 7 times 7 times 2 is 14. Is that somehow that I can get 25? No. So let's, even if we swap it around, it won't work. So let's try, let me do it over here. We cross that out. Let's try a 4 and a 1. So 4, how about a 4 and a 1? 3 times 1 is 3. 7 times 4 is 28. 28 minus 3 will give you that positive 25. So it must be a positive 28 minus 3. Which one gave you negative 3? This one over here. Which one gave you 28? This one here. Okay, so then I will have 3x plus 4 times 7x minus 2 is equal to 0. So let me just double check. 3 times 7 is 21, x squared minus 6, minus 6, no, that doesn't work out. Sorry, this must be a 1 over here. 7x minus 1. 3x times 21 minus 3x plus 28x gives you that positive 25, and and a positive times a negative is a negative 4. Cool. So those are your factors. So then you can go ahead and equal each bracket to 0. So 3x plus 4 is equal to 0, or 7x minus 1 is equal to 0. So with these ones, you would rather want to write out the steps than to make a mistake. How do I get x alone? I divide with -3 on each side. How do I get x alone? I divide with 7 on each side. Cool beans. Okay. Number C. Again, well, if you want to simplify this, you can actually divide with 2 on each side immediately. And then you get x squared is equal to 2x. So you can always simplify it. So if you divide by 2, you have to divide both terms with 2. All right. And then I've got x squared is equal to 2x. So then if I equal it to 0, that's your step 1. Then I'm going to take out an HCF of an x. So either, although it's not in a bracket, you can place it in a bracket. So either x is 0 or x minus 2 is equal to 0. Thus, x is either 2 or 0. Okay, if you didn't take out the 2 in the beginning, it doesn't matter. So then you would have had 2x squared minus 4x is equal to 0. Then you would have just taken out a 2x and x minus 2 is left. So I just want to show you, if you equal the 2x equal to 0, because you're dividing by 2, x will always be 0 there. So it doesn't matter if there's a number in front or not, it will give you the same answer as over here. Number D. All right. Oh, this looks like a trinomial. It just is muddled up. So I just need to go and reshuffle it. All right. Then I can take out a negative, because we never start off with a negative. And then basically dividing with a negative on each side, that negative will just disappear, because if you divide here with a negative and here with a negative, or a -1, 0 divided by -1 stays a 0. Okay, 0 divided by anything stays 0. So basically this x will, that negative will fall away. Then you're going to factorize your trinomial. They're the same, they're both negatives. And what about 4 times 4? And when you get two answers for x, x minus 4 is 0 or x minus 4 is 0, you can just write the 1. Okay, so x is 4. Number E, I want to show you the difference between these two. Can you see this one is equal to 0? The number F here is equal to 10. So with this one, I can go ahead and make both equal to 0. This one, I can't say that 3x minus 1 is equal to 10 and x plus 2 is equal to 10. Okay, it doesn't work like that. You have to equal it to 0. They call it the zero product rule or something like that. Okay, so with this one, you can go ahead and say that each bracket is equal to 0. And then 3x is equal to 1, or x there is -2. Thus, x is equal to 1 over 3, or -2. Okay, so what do I do with this one? I first need to FOIL out. I need to simplify. I need to go one step back to go 3 steps forward. Okay, so 3x times x is 3x squared, plus 3 times 2 is 6x, minus 1 times x is x, minus 1 times 2 is 2, is equal to 10. So now I'm going to incorporate that plus 10, I'm going to equal it to 0. So thus 3x squared plus 6x minus x is plus 5x, and minus 2 minus another 10. If I subtract 10 on both sides, it will leave me minus 12. Ugh, and the trinomial. Let's do this. Okay, 3 times 1 will give you 3. And how about 4 times 3? 3 times 3 is 9. 4 times 1 is 4. Is there somehow to get from let me rather write it at the bottom so you don't get confused. To get from 9 and 4 to get to 5, yes. So it must be a positive 9 minus 4. Okay, positive 9 minus 4 does give you that positive 5. Which one gave me a negative? This one. Which one gave me a positive? This one over here. So add my x's, and there's your 2 brackets. There is a video on this if you want to go and recap how I do the trinomial of the factorization, and I call it some of a Gaga trinomial. Okay, I'm just always checking my Gaga trinomials because I'm very scared. 3x times x is 3x squared plus 9x minus 4x does give you 5x, negative 12. Cool. Now I can make each bracket equal to 0. Or x plus 3 is equal to 0. Thus 3x is equal to 4. Divide by 3 on each side. Or x is equal to negative 3. Alright, let's quickly look at these ones. I'm going to start with number h, where you can easily see, okay, but x is equal to, if you square root each side, that you would then get x is 6 over there. Okay, so x is 6, but how about if I put it to you, what if I make x negative 6? Won't negative 6 squared, because if you have a value for x, you always replace it within a bracket, which means that negative, that negative is also raised to a power even number, so which will become a positive, and 6 squared is 36. So with these ones, you always have to remember, you can do it quick. So if you square root the x, that you must always write that it can be a positive or a negative 6. Okay, so with these ones, instead of doing a difference of 2 perfect squares, that's the other way you could have done it, x minus 2, x plus 2, thus x is either a 2 or x is a negative 2. You could have just said x squared is equal to 4. Then if I square root and square root, x will give me, and now very, very important, it can be either a positive or a negative 2, as seen over there. All right, so please, let's quickly look at these little bit harder ones. Don't know my English is correct there. So you divide by 3 just to make it a bit more simple. You can do that. Why? Because you are busy with an equation. Minus 16 is equal to 0. Thus, x is equal to, x squared is equal to 16. Very important. Please remember your plus minus 4. Okay, so whenever you've got something squared, the answer can either be a positive or a negative. So let's look over here, this harder one. If I had to square root that, that will fall away. And if I square root this, so it's either x plus 5 is equal to plus minus, and the square root of 9 is 3. So I need to go work it out twice. So it's either x plus 5 is 3, or x plus 5 is equal to negative 3. So x is either 3 minus 5, which is negative 2, or x is equal to negative 8. All right, so that if you've got, let's go replace it back. I just want to quickly show you. So if you take it back into the original. So if I got x is negative 2. So if I have negative 2 plus 5 squared, does it give me 9? So negative 2 plus 5. Negative 2 plus 5 is 3. 3 squared does give me 9. Now what if I've got a negative 8 plus 5 squared? What does that give me? A negative 8 plus 5 gives me a negative 3 squared, which also gives me 9. So can you see how the plus minus come into play? Because if you raise a negative to an even number, it becomes a positive. Okay, a negative to an even number becomes a positive. Right, let's look at solving equations with fractions. If you remember, last year we have dealt with these types of sums, so it's nothing new to you. Basic steps, if you want to follow that, you find a common denominator. So first of all, what happens is you have to factorize first. I think that's new to grade 10. You factorize first, find an LCD, drop it like it's hot, and equal the tops to each other. Okay, the numerators. Now, something that's new to grade 10 is where we apply or where we look at restrictions, what x cannot be. Now, if you remember way back in grade 8 and 9, where we dealt with the number system, we said to you that anything over 0 is undefined, which means it's got no solution. All right, so we cannot have a 0 underneath a fraction line. All right, so if you look here, what is x over here? X cannot be 0. So one of your restrictions is that x can't be, and that's how we represent the can't, x can't be 0. So that would be one of your restrictions. So if you get that as an answer, you cannot have that. And then if that's the only answer, then that would be no solution. All right, so let's have a look. So if I put this over 1, what would be my LCD? My LCD would be x. So without rewriting the whole fraction again, I'm just going to see which one had to get an x. This one over here, and what I do at the bottom, I have to do on top. So then I'll end up with 10x plus 16 is equal to 4 times x is 4x plus 16. All right, then 10x minus 4x is 6x is equal to 16 minus 16, which is 0. Divide by 6 on each side, and then I get x is 0. But if I look at my restrictions over here, it says that x can't be 0. And because this is your only answer, you're going to write, but x can't be 0, thus there's no solution. All right, so this answer doesn't have a solution. All right, if we look at number B, we're going to factorize where we can. First factorize, so it's going to be 4 over x minus 5 can't be factorized, 10 over x can't be factorized, and 2 over here I can take out a common x, and then what is left? X minus 5. So now let's have a look at our restrictions. What would our restrictions be if you look here? So remember that underneath it can't be equal to, x can't be 0. So if I make that expression equal to 0, I will see that x can't be 5. X also can't be 0. And over here, x, if you had to throw it over, also can't be 5. So basically, there's your two restrictions. X can't be 5 and x can't be 0. Okay, now our LCD would be, if I had to write it down, would be x and x minus 5. In with the first one, the first expression here, what it needed was an x, and what you do at the bottom, you do on top. Here, it needed a x minus 5. What you do at the bottom, you do on top. And over here, we needed nothing. Okay, so I'm already going to drop it like it's hot, and then just apply my multiplication that I had on top there with the numerator. So 4 times x is 4x, minus 10 times x minus 5 equals to 2. And then we're going to solve x, simplify. Plus 50 is equal to 2. So 4x minus 10x is negative 6x is equal to 2 minus 50, which gives you negative 48. And if you take your calculator and say 48 divided by negative 6 on both sides, negative 48 divided by negative 6 gives you that x is 8. Now let's compare it with our restrictions, or let's go make sure x can't be 5 or x can't be 0. Okay, so it's all good to go. Our answer is x is 8. Okay, now for one big long one, but we're going to do this. 3x plus 6, I'm going to factorize the denominators. So that one will be, they're different. The first one's a minus, and 2 times 1 plus 4 over, they're the same and they're both positives, and 3 times 1. Negative 4 over, now I want you to, sorry for that, I just want to show you, if you had to swap these around, it will be negative x plus 2, okay, because the sign goes with it. But if you look here, 2 times 1, I just want to quickly see x plus 2. Oh yeah, sorry. So if you have a look here, if I can somehow manage to change the signs to a x, to a x minus 2. So if I had to change the signs, then I will have the same bracket as there. So I'm going to take out a negative, and a negative times a negative will give you a positive. So over here, if we make that a positive, we will be left with the x minus 2 here at the bottom, which is wonderful because then it's one less thing to take out. Then our LCD would be a x minus 2 and a x plus 1 and a x plus 3. X plus 1 I already have, x minus 2 I already have. So this would be your LCD. If you look at the first one, which one was needed over here? We needed a x plus 3. So this have to be times by x plus 3. If you look at the second one, which one was needed? A x minus 2. And the last one have to get 2 brackets. We have the x minus 2, so we need a x plus 1 and a x plus 3. All right, let me just rewrite that nicely. That's a wonderful word. New word. So we needed a x plus 1 and a x plus 3. All right, okay. And then I'm going to drop it like it's hot. So I'm going to rewrite and go and simplify. So 3x plus 6 times x plus 3 plus 4 times x minus 2 is equal to 4 times x plus 1 times x plus 3. Okay. Thus, if you had to FOIL that out, 3x squared plus 3 times 3 is 9. Oh, you people, so many times you say 6. I don't know why. Okay, 3 times 3 is 9x plus 6x plus 18 plus 4x minus 8 is equal to, you can either bring the 4 in first or you can FOIL first. It doesn't matter. So I'm going to take the 4 in, and that's going to multiply with x plus 3. Okay, so you could have FOILed as well and then only bring in the 4. So let me simplify here a little bit. 3x squared plus 9x plus 6x is 15, plus 4 is plus 19x, and plus 18 minus 8 is plus 10. Yes, that's right. Is equal to 4x times x is 4x squared plus 12x plus 4x and a plus, I just want to make sure, we had an x minus 2 there. Sorry. I just doubted myself there for a while. Okay, plus 4x plus 12. Okay, now I'm going to first simplify each side completely because I don't want to make any mistakes. Plus 10. Let's bring over this minus 4x squared and a plus 12 plus 16. Plus 4 is plus 16. Take it over, it becomes a minus 16x minus 12. So someone just took everything over to the other side, and then I'm left with negative x squared plus 19x minus 16x. 19 minus 16 is a positive 3x. And 10 minus 12 is minus 2 is equal to 0. Then we're going to take out a negative. What's left? X squared minus 3x plus 2 is equal to 0. Remember, if there's just a normal number that gets divisible by 0, it basically just falls away. Okay, so then I've got the two brackets is equal to 0, and x, they're the same. They're both negative, and 2 times 1. Minus 2 minus another one gives you the minus 3, and if you multiply them thus, x is either 2 or x is 1. But wait a minute. What was our restrictions? Did we even write it up? No. So let's go have a look. So if you look here, if you had to equal each bracket to 0, you can see that x can't be 2 or x can't be negative 1. X can't be 3, x can't be negative 1, and x can't be 2. Alright, or you could have just looked at your LCD and only worked with those. So x can't be 2, x can't be negative 1, and x can't be negative 3. So this one, thus x can't be 2. Sorry, I thought it was a negative 2. But, so x is equal to 1. Okay, so we have to eliminate that answer. You have to say, but x can't be negative 2. Thus, the only answer to satisfy this equation will be x is 1. Alright, let's quickly look at solving complex equations using a suitable substitution. And I hope by now you know that suitable substitution, that we call that the K method. Okay, so over here, we're just going to replace that 1 over x with a K. So we're going to say, let 1 over x equals to k, and then we're going to have 2k squared plus 7k minus 4 is equal to 0. Trinomial, 2 times 1, and let's try 4 times 1. I think it is like this. 2 times 4 is 8, 1 times 1 is 1, so we need a positive 8 minus 1. Okay, which one gave you the 8? 2 times 4 gave you the positive, and the 1 times 1 gave you the negative. And we're going to sub there a k instead of an x. There's our two brackets. So 2k minus 1 times k plus 4 is equal to 0. Let's quickly check. 2k times k is 2k squared plus 8k minus 1k. Does say it works out. Then we're going to let each bracket equal to 0. That one I can solve immediately. So 2k is equal to, if I throw the 1 over, oops, so k is equal to a half. Alright, but please remember, we're not solving k, we are solving x. So we have to go sub it back. 1 over x is a half, or 1 over x is equal to, see, negative 4. And now we can say, okay, this one's quite easy to see because 1 over what gives you 1 over 2. So x is either 2, or over here, I'm going to multiply with x both sides, and then I'm going to divide away with that negative 4. So x is either a negative a quarter, or x is 2. I say, there we go. Then let's look at another one over here, just the bigger part. We're going to say let 1 over x minus 1 equal to k, just to simplify our lives a bit. 4k squared minus 17k minus 15 equals 0. And then we'll have to find our trinomial parts of the trinomial. So either 4 times 1 and 5 times 3. 4 times 3 is 12. 1 times 5 is 5. Oh yes, that makes it 17. Let's just see what we need. Okay, but wait now. We need minus 17. And through a plus or a minus, because can you see that the signs are different? This won't work. Okay, so let's go back to our factors and let's make it so that we can at least get a bigger number. Let's try 4 and 1, and 15 times 1. Let's try that. 4 and 1 makes, and that makes it 15. No, that won't work either. Let's try 5 and 3. 4 times 5 is 20. 1 times 3 is 3. I say, there we go. Okay, so which one gave? So we need a negative 17. So it must be minus 20 plus 3. Which one gave me the 20? This side. Which one gave me the 3? That side. So it will be 4k plus 3 times 1k, just k, sorry, minus 5. Always check your trinomials. So 4k times k is 4k squared, minus 20k plus does give you that negative 17, does it? So either k is negative 3 over 4, because I threw it over, or k is 5. But hold on, what did we make k? 1 over x minus 1. 1 over x minus 1 is equal to negative 3 over 4, or 1 over x minus 1 is 5. Multiply both sides with x minus 1, then you're left with 1 is equal to negative 3 over 4 times x minus 1, or over here 1 is equal to 5 times x minus 1, which will give you 1 is equal to 5x minus 5. So 6 is equal to 5x, divide by 5, divide by 5, thus x is equal to 6 over 5. Right, and then this side over here, 1 is equal to negative 3x over 4 plus 3 over 4, and then I can say 1 is equal to negative 3 plus 3 x plus 3 over 4 times by 4 on each side. So 4 is equal to negative 3x plus 3 minus 3, which gives you 1. Divide by negative 3, divide by negative 3, thus x is equal to negative 1/3. And there you go. Right, let's quickly have a look at solving simultaneous equations, or solving equations simultaneously. Alright, so with this part, we've got two plans that we can follow. We can either follow plan A, and sometimes plan A doesn't work and we have to follow plan B. So please don't just say, okay, I'm just going to know plan A, because plan B is so much quicker and more accurate sometimes, or not more accurate, but it's less likely to make a mistake with plan B, where plan A, yeah, it's up to you, but I highly suggest that you know plan A, but that you also know plan B. All right, and I'll show you when you can use plan A and when you can't use plan A, that you have to resort to plan B. All right, so having two simultaneous equations, meaning that we've got two variables, meaning that we've got two equations given to us. All right, so let's have a look at A. Let me just do this in another color to stand out, using plan A. So if I give you that x plus 2y is equal to 5 and x minus y is equal to negative 1, we can manipulate one of these equations to make x alone, or to get x alone, so that we've got x in terms of, or y in terms of x, or x in terms of y. So let's just use this top equation over here, and I'm going to manipulate it so that I get x alone. So x is equal to 5 minus 2y. So now, I just want to get another color here. We've got x is equal to 5 minus 2y. So that you're going to take and you're going to replace it within the other equation's x value. All right. So there where x is, we're going to have 5 minus 2y. I don't have to put it in brackets because it's the beginning of the sum. Although if it was in between somewhere in the sum, you would have to put it in brackets. Minus y is equal to negative 1. And then you've got one variable. And we can solve for y over here. So it's minus 3y is equal to negative 1 minus another 5, which gives you negative 6. So y is equal to 2. Whoop-de-doo. And now you take that y is equal to 2 and you go and replace it into which one? Any one of the top two. All right, it doesn't matter. But if you manipulate the 1, after manipulating it, you have to go push it into the other one's equation. Otherwise, you'll just get, I think, 0 is equal to 0. And then once you get the value for one of the variables, you go and replace it into any of those two equations on top. Any one that looks lekker for you. So let me take the second one because it's visible. So I'm going to use this one. X minus, and y's value is 2, is equal to negative 1. So x minus 2 is equal to negative 1. Thus, x is equal to negative 1 plus 2 will give you 1. So there's your two values. X is 1 and y is 2. All right. Then I want to show you plan B. All right. So sometimes you get two equations where you can't get the x or the y alone. Like for example, if you've got 2x minus 3y is equal to 4 and 4x minus 3y is equal to 20. All right, now if you look at this, even if you had to divide by 2 all throughout in this top one to get x as 1x, you can't divide that 3. It will end up in a fraction, and we don't want any fractions. Same with here. You can't divide by 4 all throughout, so there's no way of manipulating it so that you can get x alone or y alone. So then we're going to revert to plan B. What we're going to do is we're going to multiply one of these so that we can subtract, so that we've got exactly the same x's that we can take away. So what we're going to do is the top one, over here, if I multiply everywhere by 2, then that top one will be 4x minus 6y is equal to 8. And you can do that because you've got an equation. You can't do it with an expression. All right, so 2 times 2, okay. Then at the bottom, I've got 4x minus 3y is equal to 20. Now, plan B is, and I'm sure your teacher has maybe taught you this, is where we want to find out whether we are either going to plus or minus these two equations together so that we eliminate one of our variables. Okay, so plus or minus, very, very important. Okay, so I need to figure out if I have to say 4x plus 4x will make 1 fall away, or is it 4x minus 4x? Obviously, all of you can see that it is a negative. So 4x minus 4x falls away. But now I need to keep this up. I need to minus the bottom from the top equation. So I'm going to do it with another color so that you can see what I'm busy doing. So then I'm going to say minus 6y minus 3y. So basically what it is negative 6y minus 3y. And can you see that that will give you negative 6y plus 3y? Because a negative and a negative makes a positive. So minus 6y plus 3y will give you negative 3y. Alright, and that is equal to, so you must be careful with the signs. Okay, 8 minus 20. 8 minus 20 gives you negative 12. Then you divide by negative 3 on each side. Thus y is equal to 4. Alright, now that you've got y is 4, you go and replace it into which one? Any one, even the manipulated one, it could have been. Okay, so I'm just going to go with the original there at the top. 2x minus 3y is 4. So 2x minus 3y, which is 4, is equal to 4. So 2x minus 12 is equal to 4. Thus 2x is equal to 4 plus 12, which is 16. Thus x is 8. Okay, and you can always go test your answers as well. If I had to go and replace it back, the x and the y, does it equal those equations for me? Okay, sorry, I'm talking with a bit of a voice and a cough. I rode the Argus or the Cape Town cycle tour this weekend. Oh, it's so much fun. If you've ever wanted to do a cycle race, you must do the Cape Town cycle tour. It is amazing, the vibe and everything. But anyway, by doing that, I got a bit ill, so that's why I'm talking with a bit of a voice. All right, let's have a look at another example. So if I've got 3x plus 4y is equal to negative 24, and 7x minus 4y is equal to negative 16. Okay, so if I have a look at this, I would have to use plan B, as I can't get x or y alone. So now, can you see that these two are exactly the same? It's got a 4y and a 4y. So the only thing I need to go figure out is if I need to plus to make them fall away, or do I need to minus to make them fall away? So let's just start with a plus. So if I've got plus 4y plus minus 4y, what does that give you? So 4y, so if I had to write it out as a sum, positive 4y plus minus 4y, does that give me 0? Yes, because a plus and a minus makes a minus. 4y minus 4y gives you 0. So I need to indeed add the two equations together instead of subtracting it this time. Okay, so let's start. Okay, 3x plus 7x is 10x. And we said that plus 4y plus minus 4y falls away, is equal to negative 24 plus minus 16 gives you negative 24 minus 16, which is 20, 30, 40. Divide by 10 on each side and you get x is 4. Whoop-de-doo, so happy, we've got x. Now we're going to replace x into any one. So I'm going to do the top one. Just be careful. I had somebody in the class today who got the x value correct, but replaced it accidentally into the y. So just make sure that you replace x is 4 into the correct place. So 3 times 4 plus 4y is equal to negative 24. So it's 12 plus 4y is equal to negative 24. 4y is equal to negative 24 minus another 12 gives you minus 36. So y is equal to negative 9. And there we've got our two values. X is 4 and y is negative 9. All right, let's look at another example. Let's close it up a little bit. If I've got 2x is equal to 9 plus y, I'm just trying to get into the little bit harder ones. 36 minus 4y. So now can you see that this is not our traditional what we've had, a x and a y and then the number. You can always reshuffle it so that you've got the x and the y and the number. But as long as each and every one is standing underneath each other, you don't have to. Okay, so as long as the x's are underneath, the numbers, the y's are underneath each other, you can actually just leave it exactly as it is. But if you like your old ways, you want to rather get it in the x plus y or x plus minus y is equal to the number, you can go ahead and do that. So the easiest thing for me, if I look at this thing, is to multiply this equation and manipulate it and multiply it by 2. So then I'm just going to write the top one down again. 2x is equal to 9 plus y, and at the bottom I'll have 2x is equal to 36 times 2 is 72, yes, minus 8y. So what do I need to do with these two? I definitely need to subtract them so that I've got 0 left over here. So 2x minus 2x is 0. And then 9 minus 72 gives you negative 63. So it's 9 minus 72 gives you negative 63. And a positive y minus minus makes a plus 8y, gives you a positive 9y. Let me just show you that again. So it's a positive y minus 8y. See, we'll make it a positive. So that negative and a negative makes a positive. And now you can just solve from there. So I'm going to take that 63 over is equal to 9y. 63 divided by 9 gives you 7 is equal to y. So now we've got y. Then we go and replace it into which one? Any one of your liking. So I'm going to do the top one here again. That one. Sorry for that interruption there. Okay, so y is 7. I'm going to replace it in the top there. So it's 2x is equal to 9. Sorry, this thing keeps on jumping. 9 plus y, which is 7. So 2x is equal to 16, thus x is equal to 8. Again, when you get this in your class, go sub x and y in and make sure that your left hand is equal to your right hand, just to make sure that you got the sum correct. All right, let's quickly look at this one over here, which is totally in the wrong position if you look at the top to the bottom. As you can see, the 3x at the bottom is lying over there. All right, so what we're basically just going to do is we're going to reshuffle it. So I'm going to keep it as 3x plus 2y is equal to, I like it like this, I don't know why, is equal to 29. And then I just need to bring the x down here to a negative x. And then I want the y, which is a positive 3y, is equal to, now be careful, if you throw it over, you need to add 5 on each side, which gives me 5. Okay, are any of them the same? No, I'm going to manipulate the bottom one, timesing it by 3, and then afterwards I will check whether I need to add or subtract. So the top one stays the same, and then the bottom one will become negative 3x plus 9y is equal to 15. So now I need to ask myself, do I need to add or subtract? If I would subtract, I would have 3x minus minus, which will become a plus, which will leave me with 6x, which is not what I want. So I need to add the two equations. So 3x minus plus minus makes a minus. Sorry for that. So 3 minus 3x falls away. 2 plus 9 is 11y is equal to 29 plus 15, which gives you 44. And that gives you that y is 4. Take y is 4 and replace it into, so I'm going to take the top equation. So 3x is equal to 29 minus 8, which is 21, plus x is 7. Happiness. Right, so with this one, at first glance, it looks like a harder one, but just to show you that it actually is quite easy and doable. So what we want to do is we want to get rid of divided by 4 over there, and over here we want to get rid of this divided by 5 so that we don't have any fractions. So what I'm going to do is I'm going to times my whole equation there by 4 and this equation by 5 to get rid of that division or of that fraction. So then for the first equation, I've got 4y plus x is equal to 4. And for the second one, 3 times 5 is 15y plus x is equal to, and then 14 times 5 is 70. Goody goody. And now I can just go ahead and subtract, because can you see I've got that x and x that can fall away. So x minus x will fall away, so I have to subtract it. And 4 minus 15 gives you negative 11. Y is equal to 4 minus 70, which gives you negative 66. Thus, y is equal to, am I right to say 6? I say, because the negatives cancel out, or if you divide with a negative on each side, so you get y is 6. And now you can go and replace it into any one of your equations. I'm going to use this one over here. So 4y plus x is 4. So 24 plus x is 4. So x is going to be negative 20. And there's your two answers. Easy peasy. Oopsie. All right. The next type of questions that you can get with equations, solving literal equations, and we call this making a variable the subject of the formula. The subject of the formula means that we want to get it alone. We want to get, if you're making x the subject of the formula, then you want x is equal to whatever. Okay, and it doesn't matter if there's variables and stuff, all that side. All we want is we want x alone. Alright, so over here it says the area of a circle is given by a is equal to pi r squared. Make r the subject of the formula. So in actual fact, we want to have r at the end is equal to whatever on the other side. So we want to manipulate this whole thing so that we get r alone. Okay, so let's start with that. So if we've got a is equal to pi r squared, can you see that the first thing we can do is we can divide away with pi on each side. Then we'll be left with that. So I'm just going to rewrite that. A over pi is equal to r squared. Now, what is the inverse? How can we get the square away? By square rooting, and then the 2 will fall away and we have r then alone. But what we do on the one side is we have to do on the other side. So r is equal to the square root of a over pi. Not so bad, hey? Easy peasy. Okay, in the next one, make v the subject of the formula. If uv over v plus 1 is equal to 1. And then they just give you that, you know, that u isn't 1 and v isn't 1, which means that this thing is undefined. So what they're actually just saying is that this equation is true. There is an answer for v, and we don't have to stress about anything being undefined. Okay, so the first thing is first. I always start by taking any fractions away. So if you've got uv over v plus 1 is equal to 1, I'm going to multiply with v plus 1 on each side, so that I've got uv is equal to 1 times v plus 1, which in actual fact just gives you uv is equal to v plus 1. And now what we can do is we can divide. Okay, so we want to have v on, okay, so if you've got two v's, we need to bring those v's together so that we can factorize, so that you can take out a v so that we can get v alone. All right, so I'm going to bring all the v's together, because in actual fact we want to then, like I said, factorize. So we're going to say minus v is equal to 1. Then I'm going to factorize by taking out a v, and I'm left with u minus 1 is equal to 1. And now we can say divide with u minus 1 on each side. And then I've got v alone. So v is equal to 1 over u minus 1. Hope that makes sense. Okay, in this one, make g the subject of the formula. Okay, so we want to get this g alone. G is equal to. And again, they give me all those things that g and r and f can't be, just so that it doesn't make it undefined. Okay, so first things first, take away. We don't want fractions. So I'm going to multiply each side with gr. So grf is equal to mv squared. And remember, we want g alone, so we're just going to divide with rf on each side. And that was actually quite easy, is mv squared over rf. And there g is the subject of the formula. Right, and now we get to our last section within this topic, solving linear inequalities. And people, this is exactly like how you would solve an equation. Now, instead of an equal sign, we have the bigger than and the smaller than sign, okay, that we're going to use, the inequality signs. Now, if it's got a little stripey underneath, then it's included. And if it doesn't have, then it is just bigger than. But I'll explain it as we are doing the sums. All right, just something very important that we need to note, that when you divide away with a negative at the end, when something is attached to the x, like let's say negative 5x is equal to 10, and immediately when you divide with a negative 5, okay, sorry, if this was an inequality, not an equation sign, let's do it like that, then immediately your sign will swap around. So when you divide with a negative, very important, your sign, your inequality sign has to swap directions. So negative 5x divided by negative 5 leaves you x. You swap your inequality sign, and x is smaller than negative 2. All right, and that also, if your inequalities are wedged between two inequality signs, you're going to do exactly the same. Both of them are going to swap directions, okay, at once. So, but as we get there, we'll do examples as we get there. All right, so with the first one, so they say to you 4 times 2x minus 1 is bigger than 5x plus 2. So solve x. Solve for x. So what this means is that x doesn't have just one answer. X doesn't have is specifically like x is 2 or x is 5. It has a collection of answers. That is what you get with solving linear inequalities. Okay, so let's just have a look. Let's start doing it. 8x minus 4 is bigger than 5x plus 2. Again, you just bring your all your like terms together. So 8x minus 5x is bigger than 2 plus 4. 8 minus 5 is 3x, is bigger than 2 plus 4 is 6. Divide by 3 on each side, and x is bigger than 6 divided by 3 is 2. So x is bigger than 2. So do you see you've got a collection of answers, not just x is 2 or x is 2 or 5. It's x is bigger than 2. So this equation will be true for any value of x that is bigger than 2. And the way we always represent it on a number line, if you had to have a little number line with 1, 2, 3, 4, you don't have to have all these numbers. You just have to have 2 over there. Then you go on top of 2, you make a big circle. We are not going to color it in because it is not including of, inclusive of 2. Sorry, it's not inclusive of 2. So it must be x is bigger than. So it's going to go to the right-hand side because that's where the bigger numbers lie. Okay, if it had a little stripey underneath, then we would have colored it in. But because it doesn't, we just make a big circle, which means it's 2 onwards. So it's bigger than 2, not including 2. All right. Right, let's look at number B. So if you've got negative 2x, I'm going to subtract 1 on each side. And now, can you see, I am dividing away with a negative 2. And as soon as you divide away with a negative, what has to happen? Your your inequality sign has to swap around, and then your x and your number stays exactly on the same spot, but your inequality sign changes around. So x is smaller than 3. And the way you would represent that on a number line, so if you've got 1, 2, 3, 4, again, this is way too many numbers. You can just have a number line with a 3 on it. So if you go above the 3, you make a big circle. Do I color it in? No. And then because it's smaller than, I'm going to take it to the left-hand side. So it means all from negative infinity all the way to 3, but not inclusive of 3. This is where my answers will make this equation or this inequality true. All right, and that's how we represent it on a number line. You can keep that negative infinity there. Right, if we look at number C, can you see that if I have to times by 3 all throughout, on both sides, I will get rid of this divide by 3. So the opposite of divide by 3, I times by 3. So if I do it on the left-hand side, I'll be left with 2x minus 1. And if I do it on the right-hand side, I'm just going to write it down like this before I do it. So 3 times 2 is 6x plus 3. Then bring all your terms minus 1 minus another 3 is minus 4. And 6x minus 2 gives you 4x. And now have a look. Am I dividing away with a negative? No, I'm not. Okay, I'm just dividing away with a 4. And so my signs do not swap around. So negative 1. Okay, and then we just always write it the x first. X is smaller than or equal to negative 1. So you always read it in terms of x. Okay, and that's why I just swapped it around. So x is smaller than or equal to negative 1. So if you had to read it from this side, can you see x is smaller than or equal to negative 1. If you wanted to, you could have rather have taken the 2x over, the 6x over to that side. So then you would have had 2x. Let me just quickly do it here. Minus 6x is 3 plus 1. 2 is negative 4x. 3 plus 1 is 4. So now, do you see what am I doing? I'm dividing away with a negative 4. What has to happen if I divide away with a negative? My my sign, my inequality sign has to swap around. And can you see then that I've got the same answer? All right, so that's why it's very important when you divide away with a negative to swap your signs around. And the way you would represent this on a number line is x is smaller than -1 and inclusive of. So all you have to do is that, -1. Now, very important, because there's an inclusive sign over there, you have to color in your dot because it's inclusive of -1. And x is smaller than, which means we're going to go to the left-hand side. Because smaller than would be most -2, -3, -4. And all those answers will be true to make this equation and inequalities correct, or to match, or to make it the left side equal to the right side. No, to make the inequality true. All right, let's quickly look at these ones where you've got two inequality signs and they will always face the same way. And if you divide with a negative, they'll always swap together as well. Okay, so over here, we in actual fact want to get 3x alone, and then at the end we're going to get x alone by dividing with 3 all throughout. But first things first, can you see there's a -1 here attached to my 3x? Okay, so first we're going to try and find 3x alone, then x, but there's a -1. So what I'm going to do is I'm going to add with 1 all throughout. Why add with 1? Because -1 plus 1 will most become 0. So then at least I've got my 3x alone. So -3 plus 1 is -2. 3x, and 5 plus 1 is 6. Okay, and now what we're going to do is we're going to divide away with 3 all throughout. So what you do in the middle, you also do all throughout. So x is -2 over 3, x, 6 divided by 3 is 2. So x lies between, x is smaller than 2, but it's bigger than -2 over 3. So if we had a number line over here, and we had a 2 on this side, a 1, a 0, a -1, a -2, do you agree that this -2/3 would have lied somewhere over here? Okay, so we have to put it on our number line. But you don't have to have all these other numbers. Okay, and in fact, you also don't have to have 0 and 1 and 2. The only ones you need to have there is that. Okay, you don't even have to have the stripies, but I just wanted to show you, to represent it visually, what it would be. So x would lie between these two values over there. Lies between -2/3 and 2. Okay, so how do we represent it? You make 2 circles. Am I going to color it in? No, because there's no stripies underneath, and it lies between those two answers. All right, so when you've got x sandwiched, we always say sandwiched between your two inequality signs, this is the way you would do it. All right. All right, second last one. So if you have a look here, we've got -1/2x. So they're still attached because they multiply together. So the only one that's loosey-goosey here in the middle that's attached to the x here is a +3. Okay, can you see if there's nothing in front? There's a positive. So how do I get +3 away? I'm going to subtract by 3 all throughout. All right, -2 minus another 3 is -5. So that fell away now, all over there. Let me rather just scratch it out, and I'm left with -1/2x. And 5 minus 3 is 2. And now we can say, what is in front of the x that I don't want there? A -1/2. So I'm going to divide away with a -1/2. But now I want you to have silences going off in your head. Why? Because we are dividing with a negative. So immediately when you divide with a negative, what's going to happen? Our inequality signs are going to change direction, both of them in this case. They're going to, instead of facing right, they're going to swap around, and they're going to both be facing left now. So let's go finish this. Negative divided by negative is a positive, and 5 divided by half, you can just put in your calculator and it will give you 5 times 2, which is 10. Now, what happens with our quacky-backy? It's not facing that way anymore. It's facing to the left, and that fell away, and our x was left. And also the same with this quacky-backy. They can never face in opposite directions. They can never bump backs. Okay, so they must always face the same direction. And 2 divided by a half gives you a positive divided by negative is a negative 4. All right, so what does this mean? If I have a number line and I've got a negative 4 and I've got a 10, that my x's value will lie between those two numbers over there. So x, if you read it here, x is smaller than 10. So x is smaller than 10. So there, am I going to color my my dot? No, because it's just smaller than. It's not inclusive of 10. But x is bigger than or equal to negative 4. So at negative 4, I'm going to make another dot, and I'm going to color it in because it's inclusive. And then it goes all the way from that dot to that dot. And there's your answer represented also on a number line. And then the very last one. Okay, so we can also mix it up like this. I'm going to quickly do this one. X squared minus 4x plus 3x is minus x minus 12. And x squared plus 4x minus 3 is plus x minus 12. And over here, x squareds will fall away. Minus x minus another x is minus 2x. And over here, minus 12 plus 12 is 0. So if you divide with a negative 2, divide with a negative 2, x will be, and now very important because you divided with a negative, you have to swap your signs around, and 0 divided by anything is 0. So x is bigger than or equal to 0. And if you've got that on a number line, your 0 over there, a dot on top colored in, and it's bigger than, so it goes to the right. All right, so that is it. Everything you need to know on equations for grade 10. I hope this helped, and I hope that you could sit through the whole video listening to me. Sorry, towards the end, I was a bit sick, but I really tried to finish this video before we move on with my students. We now finished with equations and inequalities and all the types of equations. So I just want to stay on top of all the videos, and that's why I just pushed through. So sorry for a cough here or there, but yeah, I just hope that it helps, and I hope that you've understood everything that we've done. But these are all the types of equations that you can get for grade 10. Please leave a comment. Tell me something about you. Where are you from? I would love to know, and I will try my best to respond. But thank you so much for watching, and hope you have a wonderful day further. Thanks, grade 10s. Bye.